note the increasing rate of rise on the orange 50-year line and the yellow 25-year line. Again, sourced from the IPCC, the top graph shows the global average temperature 1850 to 2000, rising by 1 degree. A reduction of 5 degrees would put us back into the last ice age. Therefore, just imagine what an increase of 5 degrees would do to the remaining ice caps. The middle graph shows the global average sea level rise since 1870. The red line on the right shows when satellite data became available, and as until this time, sea level was rather an arbitrary datum for the globe. And the lower graph, the northern hemisphere snow cover since 1920. You can see the slight decline, which supports the data showing a small temperature rise. To try and identify the atmospheric conditions in past centuries, scientists drilled cores into the Arctic and Antarctic ice. The Vostok ice core, shown on this slide, was drilled by a multinational team in 1998 at the Russian Vostok base in Antarctica. They were able to drill down some 3,600 meters, and that's just over 2.2 miles. And the results were published in June of 1999 and covered snowfall dating back some 420,000 years. This next slide shows graphically the results of the Vostok core. Note the correlation with CO2 concentrations in green and the calculated Earth's temperature in black. They follow each other, and it clearly shows the last 4 ice ages. Note also that what has happened to CO2 levels recently, and the stability in the Earth's temperature over the last 10,000 years. And this is assessed to be responsible for the flourishing of the human race in this time. However, what is alarming is the prediction that unless checked, CO2 levels will nearly double by the end of this century. We've had ice in the Arctic for the last 2.5 million years, but this slide shows the Arctic ice sheet reducing in size. No sea level rise is experienced by this, as it is all floating ice. But the reduction shown indicates that the Earth is getting warmer. The severe reduction in 2007 did recover in 2008, and I regret that I could not get the data for 2009. But the Northeast Passage was free of ice in 2007 for the first time, and scientists are predicting an ice-free Arctic summer by 2050. The Greenland ice cap, on the other hand, has the capacity to raise sea level by 7 meters, with the ice being some 2 miles thick. Ladies and gentlemen, it is melting. The Antarctic has 10 times the ice of Greenland, and it is not expected to add to sea level rise in the foreseeable future due to the very low temperatures and the amount of rain and snow maintaining the ice. Nevertheless, if it were to start melting, it does have sufficient ice water capacity to add 67 meters of sea level. This slide summarizes the possible sources for sea level rise, and the most likely area is the Greenland ice cap, as it is melting at this moment. So where does this leave us? And what is the justification for the predicted 1 meter rise statement? And how much time do we have? Well, the average rate of sea level rise from 1961 to 2003 is 1.1 millimeters per year. But from 1993 to 2003, it was 3.8 millimeters per year, amounting to 380 millimeters per century. There is irrefutable evidence that the rate of rise is increasing, and the IPCC 4th annual report stated, it is likely that the incidence of extreme high sea level rise has increased at a broad range of sites worldwide since 1975. I suggest we need to prepare for a rise in sea level of 1 meter by the end of this century. So what can we do? This is a picture of Roman Rock, Simonstown, just up the coast from here. The lack of access to foundations in the future is a clear area that can be tackled now. The Needles Lighthouse in the Isle of Wight, England, is suffering from foundation erosion between the chalk and the foundations. You can see from this next slide the Needles foundations close up, and note the loss of protection and that the waves gush up through the grouting and are slowly eroding the foundations away. The shaded area on the left of this proposed plan of the new foundation casing, made with concrete of grade C45 with accelerator for 30-minute drying time, and will be built to 1 metre above current high water springs. Now is the time to dig out suspect grouting and inject from behind a cement or resin-based grout which will cure in a damp environment. Good quality grouting, correctly made, will last for many decades or even centuries. And this is a photograph of the old Eddystone Lighthouse stump, dismantled in 1882. And it shows that good grouting lasts in the most severe of locations after 125 years of total neglect. And this level of thought also needs to be applied to boat landings. With the increasing sea level, new shipping routes are opening up in areas from the Arctic passages to deeper channels being available where they were not before. The ice-free Arctic Northeast Passage will reduce the journey from Korea to Europe by 3,000 miles. And it may be that we have to make use of virtual ATOMs for a faster and cheaper response to changing seasonal landscapes. ECDIS will be required to give faster chart updates to shipping for changing depths and passages, and this is an area that will become commonplace in the future. Many of these changes will happen slowly enough for us to meet the new landscape with the existing support structures, but we will need to be nimble and have faster surveying systems available. Population migration is calculated now to be at an unprecedented scale. The IPCC fourth annual report stated, by 2080s, many millions more people than today are projected to experience floods every year due to sea level rise. The numbers affected will be largest in the densely populated and low-lying megadeltas of Asia and Africa, while small islands are particularly vulnerable. We are market-driven and respond to shipping routes, which in turn are driven to where the trade is. Population migration will change to go where that trade is, which in turn will change the main shipping routes and the ports of call. It goes without saying that all major ports are at sea level, and this photograph of Maputo, Delagoa Bay in southern Mozambique, and it is reasonable to assume that some major ports will not be able to cope with even a 1 metre sea level rise without severe interruption to their operation. The sea level rise is but one issue of climate change, and we are starting to experience more extreme weather events. This means that protection systems will be required in areas that currently experience low incidence of lightning, and lightning protection will need to be of better quality with improved levels on maintenance. A recent direct lightning strike at our Smalls Lighthouse in England proved the benefit when installed equipment was protected by the lightning surge arresters and enabled a return to service within 2 hours of the technicians arriving on site. The anticipated rise in humidity will exacerbate the already damp conditions on remote unmanned lighthouses, but good ventilation and building conditioning will reduce these effects. Many of you will recall that this particular topic was the subject of a paper presented at IALA Santander last year. And our principal civil engineer at Trinity House is putting a lot of effort into this area, and there is no doubt that this is fast becoming a growing problem and will significantly increase our maintenance costs. In Europe, we are starting to experience global dimming, but as yet we have not been able to get any useful prediction of what the effect may be and what it will have. The UK Met Office